Welcome to our complete guide on diagnosing pull-up reference signal behavior in sensor circuits. In the next few minutes, you'll learn how these reference signals work, what symptoms can mean, how to test for the real problem, and how to avoid common mistakes that waste time and money. A pull-up reference circuit typically consists of a voltage source, sensor, signal wire, and a dedicated ground. The ECU supplies a regulated reference voltage, often 5 volts, pulled up through an internal resistor, with the sensor completing the circuit toward a low reference. Before any fault, the signal reflects the sensor's variable resistance, and the ECU reads a voltage in a known range. Triangulate scan data, direct measurement, and physical symptom before choosing a fault source. The ECU doesn't measure the sensor's resistance directly. It sees only the voltage at the signal input relative to its internal ground. A change in reference, ground, or a wiring issue can all affect this voltage and potentially mislead the ECU's logic. To test a pull-up reference, back-probe the sensor's signal wire and the 5 volts reference while the circuit is powered and operating. Measure each against both the sensor ground and chassis ground. A normal signal voltage matches expected sensor output. A high or low reading may mean an open, a short, or a pulling down of the reference. Comparing signal, reference, and both grounds can reveal if the fault is with the sensor, wiring, or source. Choose the first useful test from symptom, code, and data evidence instead of guessing. If your measured signal voltage is too low, check if the reference is pulled down across all sensors on that circuit. A shorted sensor or wiring can drop it. If signal and reference are correct, but the ground is offset from chassis ground, you might have a weak ground. If only one signal wire reads wrong, suspect that branch. Always compare suspected values to other sensors on the same reference. Start with the code and symptom. Compare scan data across related sensors. Then confirm with direct measurement at the sensor and reference. Use isolation. Temporarily unplug sensors to see if one branch causes the voltage drop. This stepwise approach eliminates guessing and targets actual circuit faults. A common trap is to see a signal code or odd scan data and replace the sensor or ECU right away. But without comparing values, isolating the circuit, and confirming with measurement, you could overlook a reference fault or wiring problem. Sensor code equals sensor proof. Use evidence, not hope. Use this step to name the condition, the observed data, and the confirmation path that separates this scene from the rest of the workflow. This scene narrows the decision to one specific measurement or clue, then points to the next action that confirms or rejects the suspected fault. The visual evidence in this scene should explain why this test comes now, what result matters, and what mistake it prevents. Diagnosing pull-up reference signal behavior means verifying actual circuit operation, not just chasing codes. Use both measurement and logic to separate power, ground, and signal faults. And always work through a systematic diagnostic flow for best results. You've just learned a step-by-step method for diagnosing pull-up reference faults, so you can trust your evidence, isolate the real fault, and avoid costly missteps in sensor diagnostics.